Hello students, welcome back to the post-lunch session. Now I am going to demonstrate problem number 3 of drawing number 11. The problem number is 3.3. This is also based on simple position 2. I am going to explain this on the drawing sheet here. Please watch it carefully. This is a problem on pentagonal prism. So I am starting by drawing the XY line. VP and HP. Okay. Now the problem says the prism is resting on HP on one of its base corners. So we are going to start by drawing the top view first by taking a corner on the right side. Okay. So I am drawing a pentagon here. The pentagon is of 25 mm edge. Start with corner A, B, C, D, E. This represents the top face of the prism. Now comes the base A1, B1, C1, D1 and E1. The base edge is 25 mm in length, so I will dimension this, which is 25. So I will call this as SP2. Now how do you get the center in a pentagon? Because I need to locate the axis. This you have done in the drawing number 1, how to get the center of a pentagon. If you select this corner, this is the opposite side, just draw a perpendicular to that edge. In other words, from this corner, connect with the midpoint of the opposite side. This is called perpendicular bisector. Similarly, if you select this corner, this is the opposite side, connect this corner with the midpoint of this edge. Wherever they intersect, you get the center. That's nothing but the axis O1. This is the top view of the pentagonal prism. Now let us project it and get the front view. The height of the prism is given as 50 mm. This is the base. This is the position of the observer. C1 is visible, D1 invisible. This is O1 dash. Then B1 dash visible, E1 dash in brackets, A1 dash. Now I am going to take the height as 50 mm. 50. Let us complete the rectangle. Now I will draw these faces. This will be axis, which is a chain line. This dimension is 50. Let me name the corners. This is A dash, B dash, E dash, O dash, C dash, D dash. So this is the front view of the pentagon. Done. Now we have to satisfy the HP condition. The HP condition is a little indirectly given in this problem. It says that the topmost edge is at a distance of 60 mm above HP. We are going to keep this corner A1 on HP and we are going to rotate it like this. When you rotate it like that, this becomes the topmost edge, CD. Okay. So the condition says that CD should be at a distance of 60 mm above HP. Okay. So when you rotate it like this, what happens is CD will move up. This height is 50 mm. It will move a little more up. And that distance is mentioned as 60 mm. Okay. So there are two conditions to be satisfied here, HP condition. One is the corner A1 on HP. The second is the edge CD 60 mm above HP. That's how you should adjust your inclination. That's why I said the HP condition is indirectly given. Okay. So what to do? We'll start by drawing the locus of CD first at 60 mm. So this distance is 60. In other words, the point CD should come on this line. Okay. Now I'll start with this A1 dash on XY. And this should come on this line. So what you do now, take A1 dash as center and this length as radius. This I'll draw it by a thin line. Just to show you, you don't have to draw this line. So you are going to take this length as radius, A1 as center, and you are going to cut this line. Let us say this is C dash D dash. Did you understand? I repeat once again. There are two conditions to be satisfied in HP condition in this step. One is this corner should be on HP. So start by taking A1 dash on XY. The second is the topmost edge CD. CD is an edge. It appears to be a point here. Okay. So this should come 60 mm above HP. So for that, what did I do? I have drawn the locus for CD at a distance of 60 mm from XY line. I started with point A1 dash. I took this length as radius with compass. Take this as center and cut this. Okay. So with these 2 points now you have to construct this rectangle. So this rectangle has got 4 corners, of which you got 2. You have to get the remaining 2. Okay. So if you consider this to be a triangle, I have got the points A1 dash and C dash D dash. I can get A dash by drawing 2 arcs. Just a triangle. Okay. So that is what I am going to do now. I am going to get A dash. So let us say this is A dash. I am going to complete my rectangle. Once this is A dash, in the similar way you can also get C1 dash D1 dash. A1 dash to C1 dash D dash. This is the radius. We are going to draw an arc here. Then from D dash, from C dash D dash, you are going to take this length as radius and cut this arc. This is C1 dash D1 dash. Let me repeat once again. Under HP condition, there are 2 conditions to be satisfied. One is this corner should be on HP here, and this corner should come at a distance of 60 mm above HP. So this is the locus for that. So what did I do? I took A1 dash as center, this length as radius. I have cut this projector. So this is C dash D dash. After that I will get the point A dash. C dash D dash to A dash, draw an arc. From A1 dash you cut that arc so that you get A dash. So you got these 3 points. Now you have to get this point, the fourth corner of the rectangle. You have A1 dash, A dash and C dash D dash. This is the fourth point to be obtained. So from A1 dash, you take this radius, draw an arc. From C dash D dash, you take this radius and cut that, so that you get that point. Yes, now the rectangle is ready. You can get the remaining points. This is B1 dash, E1 dash. This is B dash, E dash. Connect them. Then this is O1 dash and this is O dash. The chain line. Yes. So this is the front view in the second step. Now you need to follow the rules of visibility and get the top view. Now this is the top face of the prism. This is the base. The top face is nearer to observer. So I am going to project it down and draw all the 5 lines visible. Before that, I will draw the locus of all these 5 points. This is the projector of A. A will lie here. Then the projector for B and E. This is B and this is E. Projector for C and D. C and D. And finally no, I'm sorry, C and D not here. This is axis, CD is here. This is D, this is C. Connect them, all the 5 points, using solid lines. Done. Now the remaining 5 points of the base, A1, B1, E1, C1, D1. Easy to identify the boundary. We are following the second rule of visibility to draw the boundary as visible. I have satisfied the second rule of visibility. The first rule is the top face is visible, all the edges are visible. This is the top face nearer to observer. The second rule is to draw the boundary as visible, dark lines. Now concentrate on the base. The base is away from observer, so all the edges will not be visible to the observer. There are 3 edges which are coinciding with the boundary, only they are visible. There are 2 more edges which are not coinciding with the boundary. So the rule says they are invisible. I made them invisible, and if they have any connections, that also becomes invisible automatically. As I was mentioning earlier, for the inner lines, the connections depends on what they are. If the inner lines are dotted, the connection also is dotted. If the inner lines are solids, the connections also are solid. So here the inner lines are solid. These are the connections. They become solid. Means invisible. You will not have a case where the inner lines are dotted and their connections are solid. That will not be the case any time. Okay? If the inner lines are solid, their connections are also solid. If they are dotted, their connections are also dotted. That's it. Now you can project the axis and mark the axis here. You will be able to show this is one end of the axis. This is the other end of the axis. Now the line O to O1 should be a chain line. But the entire line you can't show a chain line because it is overlapped by the dotted line in this portion. So I can show only this portion as chain line. O1 to A1 only you can show as a chain line. The remaining portion of the axis is overlapped by the dotted line, so you cannot show it. So that's it. That is the HP condition. Then I'll come back and show you the VP condition in part 2.